This is a getting started guide to working with two-sided projects in the software. We're going to start by looking at a brief introduction to the process and concepts of two-sided machining, and then demonstrate the process of creating a two-sided project in the software. So what is two-sided machining? So this is where we use the same piece of material, where we cut one set of toolpaths on one side, then we flip the material over and we cut another set of toolpaths on the other side to ultimately create a two-sided part. And so for this to work correctly, it's essential that we have exact alignment between the top and bottom sides of the material. So how can we create a two-sided part in the software? So we have the ability to create double-sided projects in the same session. Now, depending on what software you are using, we can create and import vectors and components on either side of your part, where you can visualize the two sides in a multi-sided environment in both the 2D and the 3D view, giving you the reassurance that everything is in the correct place. So how do we set up our part for two-sided machining? So when you first fire up the software and create a new file, you're going to want to choose to create a double-sided job. This will then put the software into a two-sided environment, where you would then go on to specify your job size. Then you're going to set your Z0 position for both sides, where you could set the Z0 off the material surface for both sides, off the machine bed for both sides, or you could opt to choose to zero off the same face. There is no right or wrong way to set this, but I prefer to set the Z0 off the same side, where the top side is on the material surface and the bottom side is on the machine bed. This way it ensures that the Z is always referenced from the same face of your material. Now it's very important here to accurately measure the thickness of your material. Something you may want to do if your material isn't particularly flat is to surface the top side so that you have a good reference face when you flip the part over. Then you'll set the XY0 position, and finally you will then choose the flip direction. This is the way that you will flip the material over on your machine to machine the other side. The flip direction influences the position of the vectors and models if you're using vcarve or Aspire, so that the geometry on each side is created in the appropriate positions relative to the opposite side. So now you have the part set up in the software, and depending on what software you are using, you can create or import vectors and components independently on either side of the material. And you can copy and move data to the other side too, where the software will position the geometry in the appropriate positions relative to the opposite side. So you never really need to worry that your data is misaligned, as the software automatically positions and aligns the data that you send to the other side for you. And using the multi-sided view, you can proof your data positions in both the 2D and the 3D view to help you to visualize your two-sided part. And then you would go on to calculate the appropriate toolpaths for both the top and the bottom side, where you can preview the toolpaths in a multi-sided environment for accuracy. Then once you're satisfied with your preview, you can save out the toolpaths for both sides and then set up your part on your machine to run the top and bottom set of toolpaths. So how do we physically align the XY location of the material when we flip the part over? Now the method we're going to talk about uses dowel holes to help us align the XY location when you turn the part over. Here you can see a picture of the top side of our part, and there is a hole that we have cut for the dowel. Here is a sacrifice sheet on our machine, and you can see we have machined two dowel holes in there, inserted the dowels, and now when we flip the part over, it should locate correctly on those two locations. Now there's two ways to approach this. Method 1 is to drill all the way through your material and straight into your spoil board, Method 2 is to drill partially through the material using asymmetric dowel hole positions. Let's have a look at both of these methods. So method 1. When you're cutting the top side of your job, you'll want to machine all the way through the part and into the spoil board, and use the same XY0 position for both sets of toolpaths. If you are going to do that, you need to have a symmetrical hole pattern so that the positions are in the same location when you flip it over. You just need to remember which way you physically flip your material over on the CNC. And finally, you also need to make sure that when you are doing this, that you cut both the top and bottom sides in the same session of machining on your CNC. This method wouldn't allow you to stop the CNC and switch it off unless you could very accurately position the XY0 to the same location. And to get around that, we have another option. So method 2, so rather than drilling all the way through the material and into the spoil board, we would look at using the asymmetric dowel hole method, where we drill part the way into the top side of the material and in a separate operation machine dowel holes into the spoil board. And so in your job, you're going to insert dowel vectors in a non-symmetrical pattern surrounding the parts that you're going to machine, and then you're going to use the option to copy them to the other side. And so using dowel hole vectors for the top side, you're going to drill partially through the top of the material. And once machining is complete for the top side, you can take the material off of the spoil board. So then you're going to set your X0, Y0, Z0 for the bottom side on the spoil board. So the first toolpath that you're going to run is the dowel holes of the bottom side, where you're going to machine them straight into the spoil board itself. Then you're going to insert the dowels into the dowel holes in the spoil board. And so with those dowels in place, you can now flip the top side of your material over, locating the part using those dowels. And then you could go ahead and machine the bottom side of your part. So there's a couple of benefits to this. So it allows us to use a non-symmetrical hole pattern because we're going to be able to reverse that pattern and machine it into the spoil board when we flip the part over. And it's nice to use a non-symmetrical pattern because we can then ensure that when we flip our material that we only have one way that we could possibly relocate it onto our machine surface. So this eliminates the fact that we might flip the part in the wrong direction to what we set in the software. The other benefit is that I don't need to run the toolpaths concurrently, maintaining the XY0 position between the top and bottom. I could cut the top side on one day, and with this drill pattern machined in the top side for the dowels, then I can take the material off, I could run other jobs, I could turn the CNC off, and then come back to it at a later date. And when I finally come round to running the other side, then the first operation on that day would be to machine the dowel holes of the bottom side of the job into the spoil board. Then I know I'm going to accurately locate what I machined first and then machine all of the other toolpaths for the bottom side, and I know that everything will line up correctly. And so the process that I've described here does require me to have a sacrifice sheet on the bed of my CNC in order for me to machine the dowel holes into. If your machine doesn't have a sacrifice sheet, then you can attach a temporary one by clamping a piece of MDF down. An alternate method that you could also use is to create a corner jig and just ensure that you can pre-size your material very accurately and that you can set your XY0 to the corner of that jig very accurately too. And so this method, when done correctly, will give you excellent alignment in X and Y. And so there are many strategies that you could use to approach two-sided machining on your CNC that you could explore, and I'm going to show you the symmetrical dowel method in this next example. The file that we're going to look at now to demonstrate a two-sided project in the software is based on one of the free monthly project files called Cool Cubes. The file I'm going to work with is an edited file which you will have access to in the project folder. So we're going to look at creating a version of one of the boxes, and these boxes are designed in a way that we cut the decorative elements on one side of the material and a series of pockets on the other side that will enable us to assemble and join them together to create the box. So let's go into the software to set up our part. So we'll go and open an existing file. And then from the project folder, we're going to open the coolcubes_edit file. Okay, so here is the edited Cool Cubes file that we're going to use in this example. Okay, so what we're doing is we're essentially creating a box where we have 4 sides. So we've got side panel, a rear panel, a front panel, and we've got the top of the box there. The bottom of the box, we're going to cut that separately. It's just going to be a simple square shape. Okay, so in terms of what's on the top and what would be on the bottom of our material, let's just highlight those vectors. So I'm just selecting those by dragging up. So any vectors that touch my selection will be highlighted there. We can see all of those here. Okay, so everything that's currently highlighted, these vectors represent the outside of the box where we've got this decoration, and then the rectangular vectors that we can see on each of these panels, these are going to be pockets where we're going to machine them on the other side in order for us to join the box together, just as we saw in the graphic in the slide earlier. Okay, you'll notice we have a dowel position over here. We also have one over here. Okay, so we've got symmetrical dowel positions there, and then we've got some text here. This text is just telling us what each part represents, so the side, another side, rear, front, and the top. Okay, so the file that we've opened was originally saved from a single-sided session. Now, as we are creating a two-sided part, we need to create a two-sided environment. So to do that, we're going to go over and we're going to click into the job setup form. So we're going to switch from a single-sided job into a double-sided job. Okay, now that we've pressed that, you'll notice we have further options within our form, and we're going to talk all about those. So working our way down the form, we need to set up our job size. So your width, height and thickness, we're going to leave that as it is. So then we need to set as a 0 position for both the top and the bottom sides of our material. So we've got 2 handy graphics here. We've got one on the left that represents the top side of your material, and we've got one on the right that represents the bottom side of your material. See, currently it's set to the material surface, and we've got these little red dots that represent where that is. So for the top side, number 1 represents the top side. We can see that's on the material surface. When we flip that material over, you'll notice that the top side is now at the bottom over here. And then for the bottom side, we're setting the Z0 on the material surface also, again indicated by this red dot. If we switch that to the machine bed, so the Z0 position for the top side, we're setting that to the machine bed, and then the Z0 position for the bottom side is also on the machine bed. Then we have the option to zero off the same side, and if we click on that, you'll see that it opposes on each one. And so if we go to the material surface, for instance, and let's say we machined everything on the top side where Z0 was set on top of the material, and when we flip that material over, we're now referencing from the machine bed for the same side. So remember, 1 represents that top side there as if it was flipped over. That's why we're seeing the red little dots there represented where they are, because we're zeroing from the same side. Now, I prefer to set the Z0 off the same side, where the top side is on the material surface and the bottom side is on the machine bed. And this way it just ensures that the Z is always referenced from the same face of your material. Next, we need to set our XY datum position. In this case, we're going to go the lower left-hand corner. And then we need to set our flip direction between the sides. So this is the direction in which we're actually going to flip our material over to cut the second side. So here we can flip that horizontally, or we could flip that vertically. Now it doesn't matter which one you choose, you just need to remember how to replicate this virtual setup for when we physically flip the material over. So we're just going to go with this option here, and then we could go ahead and press OK. So you'll notice now that I have additional icons at the top of my user interface, which are all relative to the two-sided setup, and we're going to talk about what each one of these represents. So let's come over here, we're just going to click on this icon here, and we're just going to come back to this shortly. So over on the left, you'll see this icon here. Now this icon represents the direction I chose to flip my material in the job setup form. And so being able to see this at the top throughout my session will remind me which way I chose to flip my material. So that's useful having that indication there as a reminder. Now, if I did want to change the flip direction, I can do that by simply going back into the job setup form. We could use this option to flip that vertically, press OK, and you'll notice that the icon has changed to show us the flip direction there. Now in this case, I'd like to go back and we want to switch our flip direction so it's horizontally. Then we could simply go ahead and press OK. Then we have this button over here which indicates which side I'm currently viewing. Now you can see that the arrow is pointing to the top of the block here, therefore I know that I'm working on the top side. And to switch to the bottom side, I can simply click on that, and then you'll see now that the arrow is pointing to the bottom here, telling me that I am looking at the bottom side. And you may also have noticed that my rules have changed colour, and this is just another indication to remind me that I am on the bottom side. Now, not only can I switch sides using this icon here, but I could also make use of the shortcut keys, where 1 takes us to the top and 2 takes us to the bottom. So 1 for top, 2 for bottom. Now, at the moment, all of the vectors are currently on the top side. Now I also have an additional icon here in the view toolbar, and that enables me to work in a multi-sided view. Now this will enable me to see vectors that I may have on the other side within the 2D view. It also enables me to see 3D information in the 3D view. For example, when I simulate toolpaths for both the top and bottom side, I'm able to look at both sides in the 3D view. So let's turn that on to see what happens. So we can see that it's on as the icon has changed and is currently highlighted. The shortcut key to also access this function is by pressing the equals key on your keyboard. So with that on, we haven't really seen much of a change in terms of what I can see here, and that's because we don't really have any data on the other side. So if I now switch over to the bottom side, you can see now that with the multi-sided view switched on, I can view the vectors on the other side as though I were looking through the material. Now these vectors that I can see on the other side are in a light green colour. I can't select them or edit them on this side, I can just see them. And so we can see that the text is now reversed and the top panel is now on the left hand side because we're flipping the parts horizontally. And this is very useful, having the ability to see the opposite side's data in terms of where I create new vectors relative to the vectors on the other side. And a very handy feature here is that I'm actually able to snap to geometry that exists on the other side too. For example, let's go in and draw a rectangle. So you can see I can snap to the corners here and I can draw that out so that it matches what we've got on the other side, and you can see how useful it is for me to be able to snap to the various points that are on the other side of our job. So if we just close out there and just take a look at that, let's have a look at the effect now when we turn off the multi-sided view. So if we click on that, you can see that we can no longer see the vectors on the other side, and we're only seeing the vectors that we have on this current side here. And again, if we switch over, we can just see those vectors. If we go back, we can just see the new vectors that we've created here. So let's just take those vectors there, and then we'll just go ahead and then we'll delete them. Then we're just going to go back to the top side here, and then we're just going to switch back on the multi-sided view, as this is very useful for me to see all of the information in one session. Now I don't need to create any vectors in this example. I have all of the vectors that I need to create the box. All I need to do is just organise them to their sides. So let's select all the vectors that we're going to send over to the other side. So we're going to take all of the details and the outlines by just dragging and selecting. Then we're just going to hold down Shift, and we're just going to drag and then let go, drag, let go, drag, let go, and then we'll just take all of those there like so. Okay, so we're going to take these decorative vectors along with our profile cutout vectors, and we're going to send them to the other side. So to do that, all we simply do is right click, and then we can use the option to move to the other side. When we click on that, the software will move them to the other side. Because we are in a multi-sided view, we can see those vectors have been shifted over to the bottom side there. And so with the multi-view switched on, I can see that the software has accurately aligned the vectors onto the other side based on my flip direction. And again, having this view switched on is extremely useful for us to be able to better visualize the overall part in a two-sided environment. So let's just go ahead and we'll just switch to the bottom side, and you can see that they have been moved and we're able to see the vectors on the other side there. Now, one thing to point out here is that we are using symmetrical dowel holes, and so that when I flip between each side, the dowel positions do not move, and that's because they're symmetrical. And when we flip the material over, we're going to have correct alignment in X and Y. So now I want to run through how I plan to cut the whole part. Now, in terms of machining, I plan to cut these vectors using the pocket toolpath so that we can assemble all of the panels to form the box. Then we'll machine the dowel holes going all the way through the material and into the spoil board. And that's pretty much it for all of the toolpaths for the top side. Then what we'll do is we'll take the material off and we'll insert the dowels into the holes that have been drilled into the spoil board, where we'll flip the material over horizontally in this direction and then position the material on the dowels to align the X0, Y0, and then secure the material in place. And then we're ready to machine the toolpaths for the bottom side, where we'll look at cutting the decorative holes for the bottom side and then finally cut the part out. So let's go and run the toolpath. So we'll just switch over to the toolpaths tab. Okay, so now that our toolpaths tab is open, we have another indication here telling us that we're on the bottom side. So the toolpaths list will tell you which side we're on. In this case, we want to machine the top side. So let's just switch back over there and you'll see now it's displayed as top. So the first and most important thing that we must do is check over our material setup. Okay, so working with 1/2 inch material, XY is in the lower left hand corner. Okay, so the Z0 for the top side, we've set that to the material surface. Then you just want to check over your rapid Z gaps above the material, your clearance and plunge and your home and start position, ensuring that everything is safe and appropriate for your particular setup. And once you're happy, you can go ahead and press OK. Okay, so the first toolpath that we're going to create is the pocket toolpath for all of these horizontal rectangles that we've got here. And with those vectors selected, we're going to go into the pocket toolpath. Okay, so here we're going to have a start depth of 0, and we're going to cut down by 1/8 of an inch. Okay, then we need to specify our tool, so I'm going to use the 1/4 inch end mill here. And then in terms of our strategy, I'd like to do that in a raster strategy. As we're working with horizontal shapes, we're going to ensure that the raster angle is at 0 so that it's parallel to the x-axis. Okay, and we'll just set a profile pass that's last, and then we can simply give that a name. So we'll just go with pocket 1, and then we can go ahead and press calculate. That will automatically open up the toolpath preview form where we could go ahead and preview that toolpath, and so that's what that would look like. Okay, so if we just go and pop that in Z, and then we're just going to close out of the preview toolpath form. We'll just go back into the 2D view there, and now we're going to look at machining the vertical shapes that we've got. So if we just select those and then shift and select that one as well, then we'll go back into the pocket toolpath. Okay, so this time we're actually cutting a little bit deeper. So we're going to go in at 1/4 of an inch there, starting at 0. We're going to use the same tool here. Now, as we're working with vertical rectangles, let's alter the raster angle here so that we set that to 90 degrees, so it's parallel to the y-axis. Okay, and we'll just go the same settings as before, and we'll simply go ahead and press calculate, and then we can preview that toolpath and we can see the result of that there. Okay, so I'm happy with what we've got here, so we can just pop that in Z, and then we can close out here, go back into our 2D view, and then finally we're just going to take the Dowel vector, so we'll hold down Shift to select both of those, and then we're going to go into the drill toolpath. So here what we want to do is we want to cut in through our material and also into our spoil board so that our dowels have something to latch onto in the spoil board that we can also then flip our material over on top of. So here we're actually going to start our cut at 0, where we're going to cut down 1 inch into the material and into the spoil board. Okay, so we're just going to go and use this 1/4 inch drill bit that we've got there, and then we could simply go ahead and press calculate. Software is giving us a warning telling us that the tool is going to cut through the material. The material thickness is 1/2 inch, and you've set that to cut at 1 inch. That's fine. I'm meant to do this, but the software is just flagging this up in case we wasn't meant to do that. In this case we are, so I'm going to say okay, this is not a problem, and then we could simply preview that toolpath and we can see our dowel holes there. Okay, so once we've machined these toolpaths, we'd then take this piece of material and would remove it from our machine bed. We'd then insert the dowels into the dowel holes that we machined into the spoil board, and then we can take our material and we're simply going to flip it over in this direction, as that's the direction we've got it set up here in the software, and then you just secure it to those dowels and then secure it in place, and then that way we know that our XY coordinates are going to be aligned with each other. And so now we can think about running the other toolpaths. So let's just go ahead and we'll just switch over to the other side, and then we'll just pop this view in the Z view. So that's just turning that over there, and then what we'll do is we'll go into the 2D view. So let's just close out the preview toolpath form. You can see we're on the bottom. Now if we go into our material setup, we can use the set option here just to check over our settings here. Okay, so again, checking the material thickness is correct here, XY lower left, and then the Z0 for the bottom side, we've got that set to the machine bed. Now I prefer to set the Z0 off the same side, where the top side is on the material surface and the bottom side is on the machine bed. This way it just ensures that the Z is always referenced from the same face of your material. Okay, again, check over clearance plunge, home and start positions, ensuring that they're all safe and appropriate, and then we could go ahead and press OK. Okay, so you can see that we've got a warning here about the dowel holes, and that's okay. It's just reminding us that we are going to be cutting all the way through our material on the other side, and that's just warning us here. And I'm happy to do that. We know, we're aware of what we're doing, so we'll just go ahead and press OK. Okay, so let's first start by taking the decorative vectors. I'm just holding down Shift whilst dragging with my mouse to select those vectors like so. And we're going to look at using the profile toolpath. So we're going to go into the profile toolpath here. Okay, we're going to set our start depth here at 0. Our cut depth, we're just going to cut in at 1/8 of an inch. I'm going to use this select option here to open up the tool database, whereby I'm going to look at using a 1/4 inch ball nose here. We're going to machine on the inside of those vectors, and then we could simply give that a name if we wanted to. So let's just call this one decorative holes, and then we could simply go ahead and press calculate, and then we can preview that toolpath, and that's looking pretty funky there. Like the look of that. Okay, so happy with that, so we'll close out, and then we'll just go into the 2D view with those vectors selected. We're just going to click to deselect them, and then we'll just select all of the outer vectors, and these vectors what we're going to use to run a profile toolpath to cut our parts out. So those vectors selected, let's go back into the profile toolpath form. Okay, so start depth is at 0. Cut depth, we're cutting all the way through our material, so we could enter Z followed by the equals key, and the software will input that value based on the thickness that we've set our material in the software. And so we can see 0.5 has been added in there. Okay, so then we're going to use a different tool. So we're going to use the select option here, select our 1/4 inch end mill, where we're going to machine on the outside of these vectors, and then we're going to look at adding some tabs in there as well. Okay, so we can see we've got tabs on the top and bottom of our parts and all sides on the top part, and the software's really just remembered the tab positions that was originally set in the original file for the single-sided project, and so it's just remembered that, and I'm happy with the position of these tabs, so I'm just going to leave them as they are, and then we could simply go ahead and we can give this a name. So we could call this one profile cutout, and then we could simply press calculate, and then finally we could just go ahead and we can preview that toolpath. Okay, so that's looking pretty good, and as we are in a multi-sided view, we can still see the toolpaths that we previously calculated on the other side here when we twiddle that around. Now, it's very important that your part looks correct at this stage, as the toolpath preview shows you an accurate representation of what we'd see on our CNC machine if we was to go ahead and run these toolpaths. So if something doesn't look as you wanted it here at this stage, you can go back, make edits to the toolpaths, recalculate them until you are satisfied with the results that you see here in the toolpath preview. And that's what makes this toolpath preview such a powerful tool. Okay, so now that I'm actually confident with the toolpath preview and we can see what the two sides look like, I think now is probably a safe stage to go ahead and save our file. So let's just go to File, and then we'll go to Save As, and then in the project folder, we're just going to call this one Introduction to Two-Sided Machining. Press Save, and you can access that from there. So with that file saved, we can now think about saving out our toolpaths. So let's close out of the toolpath preview, and we're going to go into the Save Toolpath form. So we are using two different tools, so we can select this option here to switch on the visibility of all of our tools here. And then what we can do is we can save these toolpaths where we're saving the visible toolpaths to multiple files. We can also use this option here to add the side to the toolpath name. And that's just really convenient, as when I come to save out the toolpaths onto my machine, I can see the toolpaths that are for the top side and I can see the toolpaths that are for the bottom side, because the software auto names them top or bottom. So we're going to check that option. That's just going to help ensure that we load up the correct toolpaths per side that we're machining. Okay, so we can see that those toolpaths are listed here in our toolpaths to be saved list. And then for demonstration purposes, we're going to look at saving that to our desktop machine that uses the post-processor G-code arcs inches. And you'll need to ensure that your machine and the post-processors for that machine are used here. And you can learn more about machine configuration and saving toolpaths in the related videos section for this tutorial. So here we'd simply go ahead and press Save Toolpath. And so in the project folder, the software has automatically given this a name, bottom_decorative holes. So the decorative holes is from our first toolpath in the list. So we're actually just going to delete all of this out, and we're just going to call this bottom. And so that will just affix this to the start of each one of these toolpaths. So if we go ahead and press save, and then if we go ahead and just open up that folder, we can see here we've got bottom 1 decorative holes, bottom 2 profile cutout, and these are the .tap files that I can then use to run on my CNC machine. Okay, so that's the bottom side, so let's just close out here, and we're just going to switch over to the top side here, and then we'll save the toolpaths for the top side. So we'll go to Save Toolpaths, and we'll just make the visibility of all of our toolpaths so that we can see them in our list. Now we've got two end mills here, two of the same tool, so we could look at using this option here to group where possible, and so it will group these two together, and then it will keep the drill tool separate. Okay, so again with the same settings we can simply go ahead, and if we just use the option to add side to toolpath name and then press Save Toolpath, again we can just go ahead and just call this one top, and then press save here, and then if we go into that project folder we can see we've got top pocket 1, so that's the 1 and 2, so that's the pocket 1 and pocket 2, and then we've got top 3, which is the drill toolpath. And so you can see how it's very handy having the bottom and the top in our toolpath names. And again, we can go ahead and take those .tap files over to our CNC machine to run them. Right then, so let's just close out here. So that really concludes this introduction to two-sided machining. And so to learn more about two-sided machining and anything else that we've discussed in this tutorial, please take a look at the related videos section for this video.